interactive session is being brought to you by the Fractal Bullseye, another one of my faves. Phase shift. Now we've had we have sine x, sine omega x, a sine omega x, but now we have omega x plus phi. This has an effect of shifting the phase of the graph, i.e. moving the graph left or right a bit. We'll rephrase this as y equals a sine omega of x plus phi over omega. All right, this plus is minus and negative. So y equals a sine of omega times x minus negative phi over omega. The amplitude will be a. The period will be 2 pi over this omega. And this shifts the phase. Namely, everything happens minus pi over omega later. So it's a horizontal shift. And a similar thing with y equals a cosine of omega x plus phi. Same stuff. Amplitude is absolute value of a, period is 2 over absolute value of omega, and the phase shift is negative phi over omega. So for example, now there's some shortcuts. If you shift the phase by 2 pi or pi halves. For example, sine of omega x plus or minus 2 pi, that'll just be sine omega x. Cosine of omega x plus or minus 2 pi is cosine omega x because of the period 2 pi. As a half period of pi, so if you add or subtract pi to omega x, then sine becomes a minus sine. If you add pi to omega x, then cosine of that will be minus cosine omega x. Okay, that's easy enough to remember. These are a little hard to remember. I'm never sure which way you plus or minus these. But when you shift by 1/2 of a phase, by pi over 2, that changes sines to cosines and cosines to sines. So if you add radians to omega x, then sine will be cosine of omega x. And its complement is if you subtract pi halves radians from omega x, then cosine will be sine omega x. These other two, there's a negative coming in here. Sine of omega x minus pi halves is negative cosine omega x. Cosine of omega x plus pi halves is minus sine of omega x. I grant that this one is the hardest to remember. You may have to actually input values and see which way it goes. So, some examples. Y equals 4 sine 2x minus pi. Well, this minus pi is as a half period. So I'll turn this into 4 sine of this to minus 4 sine of this. Amplitude is 4. Period is 2 pi over 2, which is pi. And the phase shift is 0. So, the question is, so if you said x equal to 0, sine of 0 is 0, you get a 0. Fine. 4 pi units, 1 full period later to pi, it's again 0. A half period later to pi halves, it's negative 0, which is positive. Here, the difficulty is that you have to actually substitute a value to see which one's plus 4 and which is minus. At pi over 4, if you plug it in, like minus 4 sine twice pi over 4 minus 4 sine pi halves. Sine of pi halves is 1. It's a 90-degree turn. So minus 4 sine pi halves would be negative 4. And a half period later, at 3 pi over 4, it's plus 4. So this goes from 0, 0, positive 4. If you have a sign and it's a negative in front, it starts the way by going down. So down, then up, and down, up, and down. For all these, they're asking to graph 2 waves, 2 cycles of the wave. That's what they asked in the book. Here we have, what is that? Y equals 2 cosine of 3x plus pi over 2. If we remove a 3 from both of these terms, you get 2 cosine 3 of x minus negative pi over 2. So the amplitude is this, 2. The period is 2 pi over this, 3, so 2 pi over 3. So the phase shift is minus pi over 6. So make a table. When x is negative pi over 6, this cancels to 0. 3 times 0 is 0. Cosine of 0 is 1 times 2 is 2. All right. a full period later at oh dear. A full period later, if you add 2 pi over 3 to negative pi over 6, you get pi over 2, so it is again 2. Halfway between these two of the half period, you get negative 2. And between quarter period here, at 0, you get 0. At a quarter period after this, pi thirds, again 0. So here it's 2, like that.
Professor?
Yes, sir.
I have a question. Why does it become a negative? The negative pi over 6. Why does that become a negative after it changes?
Well, it's plus a pi, so minus a negative.
Yeah. Is there a reason it's? Obviously, it's going to become a positive. Is there a reason that it's a negative?
Well, like
I guess I'm just a little.
all the way over here, which is that I wrote this as omega times x plus pi over omega, right? It is omega times x minus negative pi over. Because if you subtract it to move it right this amount, adding
Okay.
it left that amount. Yeah, that plus and minus thing, phase shifting does get that complication. Yeah, so
Okay. Thank you for explaining that.
not a problem. What I'm here for. So okay, let's proceed. Where were we? Yeah. So I did this. Y equals negative 3 sine 2x plus pi over 2. Now, okay, here we have sine of angle plus pi over 2. And sine of angle plus pi over 2 is cosine of that angle. So we can rewrite this as minus 3 cosine 2x with an amplitude of absolute value of negative 3 is 3. Period is 2 pi over 2 is pi. And this has no phase shift. So when x is 0, plug in 0, minus 3 cos 0, minus 3 times 1 is negative 3. 1 full period later at pi, it's again back to negative 3. At a half period later, it's positive 3. And in between, at pi over 4 and 3 pi over 4, it's 0. So negative 3 to 0 to 3 to 0 to negative 3, and you keep going like that. Here's y equals negative 3 sine negative 2x plus pi over 2. All right, again, we have sine of angle plus pi over 2. And sine of angle plus pi over 2 is cosine of that angle. So we'll rewrite this. Minus 3 sine negative 2x plus pi over 2 is the same thing as minus 3 cosine of negative 2x. Then we use the fact that cosine is an even function. It absorbs the negative side. So minus 3 cosine negative 2x is minus 3 cosine positive 2x. Amplitude is absolute value of this, which is 3. Period is 2 pi over 2, which is pi. And so, in fact, you get the exact same graph as this one. Oh, it's not much different. Is it? No, it's not much different at all. Okay, so minus 3 to 0, to plus 3 to 0, to minus 3, and so on, all the way forever. Now here we have an inverse problem. We're given the amplitude, the period, and the phase shift. We want to find the equation of the sine function. So, okay, y equals a sine of omega times x plus pi over omega. Now, the amplitude is 3, so absolute value is 3. Well, I guess you really have to say plus and minus 3. But I'll assume it's a positive 3 because we're shifting from positive sign. Period is 3 pi, so 2 pi over omega is 3. After a bit of algebra, omega is 2/3. And phase shift is negative 1/3, so minus pi over 3 is negative 1/3. So pi over omega is positive 1/3. So get 3 sine of 2/3 times x plus 1/3. And that concludes that. Excuse me.